Okay, this lesson covers significant figures in calculations. So once you know what significant figures are, you still need to know how to manage them in calculations. And this is very important in lab and also in the classroom when you do problems, because if you just punch in the numbers in your calculator, you'll get quite a long number that has a lot of figures, that has a lot of digits to it. And without knowing what significant figures are and how to manage them in the calculation, you don't know what to write down or what the teacher wants you to write down, which is a very important thing in chemistry. And I go back to the common experiment in general chemistry where you determine the density of pennies by, first of all, weighing the pennies. So if I have 8 pennies and I weigh them, they're 19.325 grams on a milligram scale. What is the mass of 1 penny? Well, divided by 8, right? And this is the number that the calculator gives me, 2.415625. Well, should I write down all of those digits, or which one should I write down? This is what I have to figure out. And I can measure the volume in a graduated cylinder, 2.24 milliliters with the method that I have. And density is grams divided by milliliters. And I do the division problem in my calculator, and I get a pretty long number here. It fills up the whole screen of the calculator. And, you know, should I write down the whole thing? Or is the teacher going to give me points off if I write down the whole thing, right? What are the rules for significant figures here? And this is what we're going to cover in the next few slides. First, we have to cover rounding off, which is something, you know, you probably have come up with at some point, but we'll just cover it, make sure that everybody's on the same page. If the first digit to be dropped is 4 or less, then all the following digits are simply dropped from the number. So if I want to round 24.546 to 3 significant figures, 3 significant figures are 2, 4, 1, 5. And so I'm going to drop the 4 and the 6, drop them, and since it's a 4, right, then I just keep 24.5, right? If the first digit to be dropped is 5 or greater, then the last remaining retained digit of the number is increased by 1. So if I'm going to round 24.546 to 4 significant figures, 2, 4, 5, 6 are significant, and 2.54 are significant, and 6 is going to be dropped, but if I'm going to round it correctly, I have to increase 4 by 1, so it's 24.55. Sorry about my disappearing 2 there. Right, so this is the rounding off issue, right? So it's pretty straightforward, but just have to remember that's how it's done. And look nicely how we kind of use significant figures as part of the rounding off process. Another key thing here. So significant figures in calculations, multiplication, and division. So the rules for multiplication and division are a little bit easier than addition and subtraction, so we'll do multiplication and division first. In multiplication and division, the final answer is written so that it has the same number of significant figures as the measurement with the fewest significant figures. So I have 8 pennies, and I want to know what the mass of 1 penny is. I'm going to divide 19.325 by 8, and I get 241,562. So how many significant figures does 19.325 have? Should have 5, right? All non-zero numbers are significant. And how about 8? Has 1? Whenever the teacher says something like that, you say, no, 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 it's not right. Does 8 really have 1 significant figure as well? Okay, this is an issue, right? Because there's 8 pennies, right? 8 pennies is simply the number of pennies that there are. It's not a measurement. It's just a counting, right? This is a counting number. So since it's a counting number, it is considered to be exact. Right? Counting numbers are considered to be exact, which means that they have no limit to the number of significant figures that they have. That you assume that it has an infinite number of significant figures in terms of calculations. So 5 and not 1, but infinite, you could say. Which is smaller? Well, 5 is smaller than infinity. Okay, so we have 5 significant figures in the answer, and 2.4156 should be good. 2.4156 rounded off, right? I'm dropping the 2 and the 5, which is okay. Drop 2 and a 5, and I keep the 6, right? Rounded to 6, and I keep the units in there. Okay, so it's straightforward. If you know significant figures, it's straightforward. All you do is the final answer has the same number of significant figures as the measurement with the fewest significant figures. Here was a little twist to it because we had an exact number in there, but not to be scared. It'll all turn out okay. Okay, we already determined that the mass of 8 pennies has 5 significant figures, right? 5 sig figs. And this one here, the volume, has 3 sig figs. So if I do the division, how many significant figures does the answer have? The answer only has 3 significant figures, and everything else has to be dropped. Look at all those wasted numbers you have in your calculator. All right? And here we have to remember when you write the final answer that we have to round it up, right? We got rid of the 7, but since it's greater than 5, we round it up. Units are in grams per milliliter. And yeah, think of all those wasted numbers, and you almost wrote all those numbers down, right? And you didn't even have to, right? Think of what a time saver this is, right? Not having to write down all of the numbers on the screen of your calculator. But you have to follow the rules, right? It's not a guessing game. There are rules, and they're pretty straightforward. Addition and subtraction is somewhat different than multiplication and division. In addition and subtraction, the final answer is written so that it has the same number of decimal places as the measurement having the fewest decimal places. So now we're looking at not the total number of significant figures, but the decimal places. So one way we can do this is by kind of visualize this, is by doing it in the old stacked way. Let's say I'm doing the addition, like I did in first grade, by stacking the numbers. And that's really bad looking 4, sorry. But I'm going to do the addition, 36.145. So what the rules say is that I can only go to the tenths. The tenth place is the last significant place. So the 4 and the 5 in this addition calculation are not significant, right? That they're not significant, and the number here is 36.1. So here we drop the units stuff because we're just trying to streamline this and talk about the numbers. But in a real calculation, right, you're going to probably have some units that go along with this. So how about this one? How about the subtraction problem? So stacking it is a good, if you're just getting familiar with this, stacking it is a good way of doing it. And here I do the subtraction. The answer is 12. But is the answer really 12? Well, it's actually, the rules say that the tenths place is also significant. There's a 0 there, but the 0 can be significant, right? The 0 at the end of a decimal number is significant. So that's fine. That has 3 significant figures, right? And the rules tell me that the tenths place is significant, so we have to put that 0 in there to show that that's a significant position. And this takes some practice. You have to go through this and do it slowly, review what significant figures are, and review what the rules tell you is going on. We can even do this in complex calculations. We don't have to be scared of things that are a little more complex. Complex calculations, you do things in order of the operations that you do in the calculations. And the order of operations is typically parentheses, exponents, multiplication and division, and then addition and subtraction from left to right. So that's the accepted mathematical kind of order of calculations. And you have to determine significant figures at each step. So here, the first step would be the one between the parentheses. 12.045 plus 7.21 is going to be 19.255, and 4.25 squared minus 1.2. So significant figures tells me that I have to drop the 5, right, because the hundredths place is significant on 7.21, and I have to drop the 5 and round up to 19.26. And then 4.25, if I put that in my calculator, the number that I get is 18.0625. And now I need to round that one off to the correct number of significant figures. So squaring something is simply multiplying 4.25 times 4.25. So how many significant figures? I should have 3 significant figures. Right, so I have to drop, here I'm dropping the 5, here I drop the 6 and 2 and the 5. Just use a red one to drop the numbers, right? Just slashing them through 18.1, right? We have to round it up because there's 6. And minus 1.2, we can't forget that. Okay, so next operation is the division. So if I'm going to do the division, 19.26 divided by 18.1, I put that number in my calculator. It's 640. 64088. And I'm going to subtract 1.2. The operation tells me I can only have 3 significant figures, so I have to drop the 4088. Sorry, I messed that up a little bit, but I'm going to drop it anyway. So that's my excuse for not being able to write correctly. So we were going to drop that one anyway. And now I'm finally going to do the last operation, addition and subtraction from left to right, and put this number in the calculator. It's going to be 0.14. But wait a minute, are these all significant? Well, here goes to the 10th place, here goes to the 10th place, and the 100th place, so I have to drop the 4. I have to drop the 4, and my answer is minus, or negative 0.1. Wow, that's kind of surprising, isn't it? We went through this whole thing, and here's a number with, 5 significant figures, 3 significant figures, 3 significant figures, 2 significant figures, and the answer only has 1 significant figure. So, there's a lot of wasted numbers out there, and you can't just guess. You can't say, well, the number here, 1.2, has 2 significant figures, so the answer must be in 2 significant figures. That's called guessing. That's saying I'm not going to follow the rules. I'm just going to make a guess. But if you go through methodically, do the significant figures of each step, done in correct order, you come up with an answer that everybody will come up with the same answer, right? That in a standard form that employs a correct number of significant figures. And this is a pretty complex problem, but it shows you that even the complex problem can be broken down, and you just take it step by step, and you determine the number of significant figures at each step, and you're good to go. And thank you for listening.